So let's take a look at this piecewise function and let's figure out what the limit, we're going to try to figure several things out here. Questions are, what's the limit as x goes to 3, which this is that question, but we also want to know what the limit is when x goes to 5, and we want to know what the limit of f of x is as x goes to, say, 0. So this really has to do with piecewise functions, and do you understand how piecewise functions work? So let's first graph this piecewise function. Notice that the first part, the first piece of that graph is a parabola. I'm going to color code this. I'll do this in green right here. So this is a parabola, and the vertex is at 3, 3. 1, 2, 3, 1, 2, 3. There's your vertex, and it's a parabola, so it goes up parabolically. Quadratics go up like a parabola. This other piece, oh, sorry, let me stop. So that's only defined, though, when x is less than or equal to 3. So I need to erase this part of the graph because it's not defined there. The other piece of the graph, we'll do in this rusty color here, is a line, and it's only defined when x is greater than or equal to 3. And let's just plug in 3. I always like to plug in that value right there to see sort of the starting point. So that's 6, negative 6 plus 12, which is positive 6. So it goes up like that. So it's positive 6, it's up there, and the slope is negative 2. So it's going to go down 2 over 1 to the right like that. That's the graph. Roughly is going to be like that. Just to be fair, let's figure out what the intercept is. The x-intercept is going to be, the x-intercept is going to be, you can just tell by looking at it, it's going to be positive 6. So 1, 2, 3, 4, 5, 6. There was my point right there, and my other point was at 3, positive 6. It was up here. Oops, like that. So my graph is going to do like that. All right. So I'm graphing this because now it's easy for me to see what the limits are. And let's think about, first of all, the limit as x goes to 0. I'm sorry, as x goes to 3. You'll notice that if you're on the graph and you're coming from the left, imagine being on your graph, like imagine being on with a graphing calculator and using your trace function. You're tracing it down, and as you get closer and closer to 3 from the left, what is the value of the f of x? What's the value of the function getting closer to?
3.
It's getting closer to 3 right here. But when you're on the graph on the right and you're going closer and closer to 3 from the right, what's the value getting closer to?
6.
Positive 6. So the limit does not exist.
What?
The limit of this graph at 3 does not exist.
Why not?
Because the limit has to be, nope, the limit has to be the same from the left and the right.
Oh.
The limit does, now the limit from the left, if they were asking you what's the limit as x goes to 3 from the left, that would equal positive 3. And what's the limit as x goes to 3 from the right, indicated by the little positive sign in the superscript? That would be positive 6. But they're asking what's the limit as x goes to 3, and it's different from both sides, so therefore the limit does not exist. So the limit does not exist. Now, someone might say, well, do I have to graph it to know that? And the answer is no. You don't have to graph it. If you originally just recognized that these two, the point in the concern is at x equals 3, and that's where I'm looking. I'm asking for the limit as x goes to 3. So if I wanted to, I could have just plugged them in, and I could see that when I plug in 3 up here, when I plug in 3 for this x up here, it gives me positive 3 as the answer. And when I plug in 3 for this x right here, it gives me positive 6 for the answer, and you could recognize that, well, those aren't the same, so the limit must not exist, because there's going to be at 2 different places. But if I was asking a question like this, what's the limit as f of x goes to, or as x goes to 5? That's the limit of f of x. Well, now I'm saying, here's 5 right here, and I'm looking at this point right there. Whatever that point is, notice, does it matter if I'm going from the left or from the right? It doesn't. The limit is the same. It's that point right there. but which line is this on? Is it on the green? It's on the brown line or the rust-colored line. So I have to plug 5 into this one because that's the point that I'm looking at. And when I plug 5 into there, I get 2. So what's the limit of f of x as x goes to 5?
2.
Positive 2. And likewise, what's the limit? Change the color one last time here, orange. What's the limit as x goes to 0 of f of x? So let's look at 0 right here. There's 0, and it's going to be on the green line. If I plug in 0 for x, negative 3 squared is positive 9, plus 3 equals 12. So this eventually would hit up here, right there. Would
Okay.
eventually hit up there, and so the answer for that one is 12. That's how you do those problems.
Okay.